I'm Kyle Schumann.
I'm Katie McDonald.
We're assistant professors of architecture at the University of Virginia and co-directors of the Before Building Laboratory.
I direct material research.
And I direct robotic construction at the lab.
As a lab, we seek to unearth the spatial potentials of new technologies and material systems. Our work takes shape as prototypes, demonstrations, permanent structures, models, and technologies.
The Before Building Laboratory advances sustainable construction by pioneering renewable carbon sequestering material assemblies. So we know that the need for sustainable construction systems is immediate and immense. The built environment accounts for 39% of global carbon emissions. The UN Environment Program projects that 2.3 trillion square feet of new construction will occur by 2060, so this is doubling the building stock globally from the year 2023. And the laboratory leverages and develops emerging technologies to minimize construction waste, reduce labor strain, and make renewable grown materials viable for construction. We make use of consumer-grade technologies and invent our own low-cost ground-up construction systems to make it easier to work with these sustainable materials.
We often marvel at trees. Their raw, arcing forms balance a search for light, water, and structure. We consider how we as architects can leverage this material intelligence, its geometry, its behavior, and its performance. Building our lab during a time of increasing environmental peril has shaped how we design, how we source material, and how we manufacture. Every design decision is a negotiation between material, technology, and access. The laboratory's current work focuses on the future of wood construction. Carbon sequestering, renewable, well-codified, and used in buildings globally, timber offers familiarity and a short runway to broad adoption. This makes it a key material in the effort to reduce the carbon impact of construction. Recent developments in mass timber also enable the construction of tall, resilient structures. Here in Virginia, we're located within the southeastern wood basket, which supplies over 60% of timber harvested in the US. And Virginia is home to an expanding wood product ecosystem. Its forest products and industries account for $23.6 billion annually and support over 100,000 jobs.
We work to develop timber structural systems and advanced manufacturing tools. This technology is a robotic sawmill developed here at the University of Virginia. We developed this technology and filed a full patent application in May of 2025. Our current work aims to bring academic research to industry, positioning UVA as a destination for innovation in mass timber construction. A key focus is to identify the spatial potentials of these new material systems.
A key application of this approach is Sylvan Scrapple, a project exhibited at Exhibit Columbus Public by Design in 2023. The project is a 110-foot-long snaking wood wall composed of arced boards cut on the custom robotic sawmill that we developed.
Crinkle Cuts is a demonstration pavilion we built in 2024 using the custom robotic sawmill. It's constructed using beetle kill ash. This is ash that's been felled by the invasive emerald ash borer. And the logs were cut into wavy boards in two directions, meaning that we can layer these into lightweight timber panels. The assembly is the second large-scale proof of concept using this robotic sawmill technology. Moving forward, the laboratory is working on taking the technologies we've developed to industry partners. So we're really excited to bring these ideas beyond the academy and out into the world. Part of this effort is using the tools that we've developed to create new structural timber systems that offer different benefits from existing mass timber systems. We see the development of technology and material in parallel, and so we often go back to saying, what are the tools that we use, how are they enabling different material systems, and how do we need to edit or create new technologies to allow us to work with materials in new and different ways.